Let's try a few more advanced SQL features. I've been logging heart rate for each of my exercises, and I haven't done anything interesting with this data yet. So now it's time. I did a little research on the internet, and I found that the maximum heart rate is 220 minus your age. So one thing I can do is query my logs to see if my heart rate ever goes above max, since that would be pretty scary, or tell me that there's something wrong with my heart rate checking device. Okay, to do that, I'm going to do a count star. So count star from exercise logs, and then where heart rate greater than 220 minus my age, 30. Woohoo, there's no results, and that makes my heart happy. Now, notice I'm using the subtraction operator, and in fact, I can use most math operators in SQL, like to add, subtract, multiply, or divide. And if I need to, just like in math, I can throw in parentheses and change the order of evaluation. All right, so we've confirmed that my heart doesn't go above max. That's good. Now let's look to see if my heart gets into the target heart rate zone. And that is 50 to 90% of max. So we're going to start with our count star, and we just need to change our where. So this time we're going to say heart rate is greater than, and let's look at 50% of max. So that's 220 minus 30. Okay, so you see I'm combining a few math operators here. And I'm going to also throw in the round function just to show you that we can use that function. It's pretty nifty. And then we're going to say and I'll just copy paste this and change it to less than 90. Let's go ahead and throw a equals in there. All right, so now we're checking to see 59% of max, and we see there are 4 logs that fall in that target zone. But what about my other logs? What zones are they in? We don't know. All we know is that 4 of them are in that target zone. The rest could be maybe they're 90 to 100%, maybe they're less than 50%. What I would really like to see is a summary of all my logs and how many were in each of the heart rate zones. Now that sounds like a situation where I would use a group by, like group by this column that says which heart rate zone this row is in. But I don't actually have a column like that to group by. Well, I can effectively create a column using the case statement. Now I'll admit that I find this the trickiest statement to use in SQL. So I struggle with it a bit, and don't worry if you find it a bit odd as well. It's similar to an if or a switch from programming languages, if you're familiar with those. Otherwise, don't worry about it. All right, so I'm going to use case, but I'm just going to start with outputting what we know, which is type and heart rate from exercise logs, and see what that looks like. Okay. Now, for each of these rows, I want to add a new column that says which zone the heart rate is in. To do that, I go into the select part of the query, and I'm going to write case to begin the case statement. Then I type when, and the first condition, which is checking if it's above max. So that was heart rate greater than 220 minus 30. Then I write then and an expression, which is just a string. So we'll say above max. Okay, so this is my first case. Now I'm going to keep going with my other conditions. So when heart rate is greater than 90, then we'll say it's above target. And then, so if greater than 90, and then we'll say at that point, if it's greater than 50, we can say it's within target. And everything else would be below target. So I could do another condition for that, but I can also just be lazy or smart, however you want to think of it, and say else below target. Okay, now my conditions are all done, but I haven't told SQL what to name this new column. For that, I write end as HR zone. Awesome. So now for each of the rows, I can see the new column with a nice description of what zone they're in. Now that we've done that, finally, I can make a query that summarizes how many of my logs are in each of the zones. And that is a whole lot easier now that I've set up this case. I'm just going to take this query here, copy it, and I'm going to group by the new column we created, and then add count star, get rid of the heart rate, see what we have here. Aha! And now we see that we've got 4 below target and 4 within target. That's pretty neat, huh? That case statement, it is a tricky one, but it sure is handy once you get the hang of it. You may not use it all the time, but it's good to know just in case. I've set up 2 tables in this database. A students table with detailed information about each student, like their name and email, and a student grades table, which has their student ID, test name, and grade. Let's see what happens if we just select everything from student grades. Ta-da! Okay, so we see student IDs, test names, and grades. I'd actually rather be able to see student names, emails, that sort of thing. Now, what you might notice is that the student ID in student grades is related to the ID in students. So this 1 here is actually referring to Peter Rabbit, and this 2 here is actually referring to Alice in Wonderland. Now, I want to form a query that will output the student name and email next to each test grade. And that information is in 2 different tables. So that means I need to join the tables. And there are a few ways that we can do that in SQL, and we'll try them all out actually. The simplest is called a cross join. And I can make that happen just by putting both table names after the from. Ta-ta! So as you can see, lots of rows. And basically what this did is that for each row in the first table, it created a row for each of these rows here. That means we end up with 8 rows because it creates 4 rows for each of these 2 rows. This is the simplest join, but it's also the least useful. We don't want every row matched with every other row. We only want them matched if the student ID matches. Now we can do that using an inner join, which isn't actually much more work at all and is way more useful. So there's actually a few ways of doing an inner join. We'll start with just building off the last query, and we can add a where. And the where will check to see that the student ID matches students.id. All right, so now we actually have what we wanted, is test grades next to names, because it's done the cross join and then just limited to the rows where those columns were the same. Great. This syntax here is called an implicit inner join, and it works, but it's not actually the best practice. The better way is if we do something called an explicit inner join. And that is using the join keyword. So to do that, we're going to start with just doing from 1 table. And actually, I'll do from students, and then join on student grades. And then instead of where, we do on. And that specifies what columns are being matched. So on students.id equals students grade dot student ID. All right, so now we have the same results as before. Switched, but really the same. Now that I have these tables joined, I'm just going to whittle down the columns I'm outputting to the names, the email, the test name, and the grade. Okay, beautiful. Now, the cool thing is, once we've done joins, we can still use where and group by and all those fancy things. Like, let's say that we want to filter down the results to just grades greater than 90. Woohoo! Let's see. Oh, no. Grade. There we go. Haha. Lots of ones above 90. Now I can email all those students with a high five. Okay, but what would happen if my tables both contain columns with the same column name but different meanings? Like right now, our student grades table has a grade column. Well, what if my students table also had a grade column for their overall class grade? That would mean down here, when we selected grade, it wouldn't know which table to pull it from because there'd be a grade column in both of our tables. So actually, to be super safe, we should prefix our columns with the table name that they're from. So we say students.firstname, students.lastname, students.email, studentgrades.test, studentgrades.grade. Okay, now we know that we're going to get the columns from the table we expect them to be in. Great. Now that is our basic explicit inner join, and it is what you'll use for most of your joins across related tables. But if you stay tuned, I'll show you a few other types of joins as well. I'm back with my related tables about students, with the students and the student grades, and I added a new table to keep track of what projects students are working on. And once again, this one has a student ID to relate it to the students table, just like the student's grade had. And it also has a title for each project. Now what I want is a list of student names and the projects they're working on. So that means I need to join student projects with students. We can do that, as you probably guessed, using an inner join that we just learned. So what do we want? So we want students.firstname. We want students.lastname. We want the title of the project, so from the students projects table. And then we'll say from students, join student projects, and on students.id equals student projects.studentid. All right, so I see one project, Peter, and his very promising catapult experiment. But where is my other student, Alice? Well, we're missing Alice because an inner join only creates rows if there are matching records in the two tables. There's no row for Alice because there's no row in student projects that has Alice's student ID in it. And this makes sense, and oftentimes with joins, we do only want rows where the records matched. But in this case, we want a comprehensive list of every student and their project, and we want every student to be on that list, even if they don't have a project yet. And that is where an outer join is super useful. And it's really easy to use. We're just going to go right here and type left outer. Ta-da! Now we see Alice, and there's a big old null for the project title. Okay, so how this works is that the left tells SQL that it should make sure to retain every row from the left table, which is the one after the from, students. And the outer tells it that it should retain the rows even if there's no match in the right table, which is student projects. And that's our outer join, and there's a lot of cases where you might find you want an outer join, and just keep in mind that the behavior of inner versus outer joins. There are also some other sort of outer joins. There's a right outer join, and it basically does the opposite, is make sure that it keeps everything from the right and then joins with the left. We don't actually support right outer joins here, but if you want that, you can just switch the table order and it's the same thing. So you don't actually need to have a right outer join. You can always use left outer join. And there's also something called a full outer join, and that matches rows, if it can, on both the left and the right side, and fills in nulls when it can't on either side. And that's pretty interesting, but also is not supported in our environment here. And that is one of the interesting things about learning SQL. I'm showing you lots of things that work here and work in other SQL environments, but every environment is a little different. So you'll constantly be tweaking the tools in your SQL toolbox for each new environment. And that's true about a lot of things with computers, honestly. You'll learn the general techniques and then learn how to adapt it for a specific language or app or environment. And you basically just get really good at learning. I'm back with just the table about students this time. I've added one more column to the table, buddy ID. See, I decided that every student should have a buddy, somebody that they can pair up with, do assignments with, study with, all of that. Now, the buddy ID is what it sounds like. It's an ID that relates to the ID of the student that they're buddied up with. So, for example, here, Peter is buddied up with 2, and 2 is Alice. Let me just do a select that should make that more clear. So select the ID, first name, last name, buddy ID from students. Okay. The interesting thing here is that this buddy ID is a column in a table that's related to another column in the same table. That's a bit different from before, where we'd have columns related across different tables. So, what if we wanted to show the names of each student next to the email of the buddy? Not just the ID, the email. To do that, we need to actually join the students table with itself because the 2 bits of related data that we need both happen to be in the same table. We can do that by, let's see, so we want the first name, last name, email. So to join students with itself, we're going to write from students and then join students. Okay. All right. Okay, so we get an error. First name is an ambiguous column. And that's true. We're telling to select first name, but it's joining across 2 tables, and both of these tables have the same column names. And before, we would just prefix these with the table names, but we can't do that here because actually they're both named students. So we need to give it a way to distinguish between this one and this one, even if they're kind of the same thing. And we can do that by giving one of them an alias. So we're going to write the alias right after here. The alias is like a nickname. So here's the alias, buddies. And then we just have to specify that the email is coming from buddies.email. Haha. There we go. Now we're seeing too many rows, way too many rows, and that's because we don't have an on clause yet. So it's just joining every possible row with every other one. Now our on should check that the buddy ID from the students table, that first one, matches the ID from the second table, buddies, or what we called buddies. Haha! Now we can see Peter with Alice's email address, Alice with Peter's, etc., etc. To make this results table even a little more clear, I'm going to rename Buddy's email as Buddy email. Okay, so now it's a lot more clear that we're looking at Peter Rabbit and his buddy's email. Cool. Now this type of join is called a self-join, and that's because it's a table being joined to itself. Now I want to show you a combination of joins and self-joins. So this time I'm back with multiple tables, tracking the students and their projects. Now, since I have students working on great projects, I want them to review each other's work in pairs. For example, hyena habitats should review carpet physics. That's why I've created this new table, project pairs, and all it stores is 2 project IDs that are paired with each other. Now, let's see. What do I see if I select star from project pairs? Okay, it's just a bunch of numbers, a bunch of IDs, all the IDs that are mapped with each other. It is not the most human readable output at all. What I'd like instead is rows of project titles paired with each other. The project titles are in the student projects table. So that gives me a clue that I need to somehow join project pairs with student projects. Let's see what happens if I do that. Aha! So now we see project IDs and project titles in each row. What I eventually want in the results table is to see 2 project titles in each row, not just one. So that's another clue that we need to do another join, a self-join of student projects with itself, so that we can get those same column values twice. Now, it may not be obvious how to add a self-join at this point, because we already have a join. If we want to add another one, we can actually use the join keyword again. So join student projects, and we need to make sure we give them different aliases so that they're not ambiguous. So A and B. All right, so now we've got a lot of stuff in this results table, but if you'll scroll, you'll see that the project titles show up twice in each row. So maybe let's make it easier to see. A.title, B.title. Great. But we still have way too many rows because we're matching every row with every other row, and we haven't added the on clause, the very important on clause. So we're actually going to add 2 on clauses, one for each of the joins. So on project pairs, that's project 1 ID equals A.id. And then on project pairs dot project 2 ID equals B.id. Aha, there we go. So thanks to this combination of joins and self-joins, we can see a nice list of project titles paired with their project title. Let's say that we want to create tables to store the data for a diary app. A basic setup would be a users table and a diary logs table. Now, when a user wrote up their diary on the website, we would have some code to execute an insert statement like what I'm pasting in here. So this inserts 2 rows for 2 diary logs, one day after the other. First, where somebody has a horrible fight and buries their woes in 3 pounds of dark chocolate, and the next day, of course, they make up and celebrate with ice cream, as you do. So we can check to see what our diary logs table looks like now, and we can see those 2 posts in there. Now imagine that the user comes back and wants to modify their logs, maybe because they don't want to admit even to themselves that they have eaten that much dark chocolate. Now we've already inserted the data, so at this point we would need to have code that would execute an update statement like this. Update diary logs set content equals I had a horrible fight with Ono's guy. Now this is telling it to update that table and set the content, but it's not telling which row to update. We need to tell the database which row to update because we don't want it updating every row with that content, just one row. So how do we find the log to update? Well, we can use the ID like that. If we didn't know the ID, we could also filter by columns that we knew were unique to the log, like user ID and the date. It was 2015 0401. But really, if you know the ID, it's safer because you're not relying on having to filter on columns, which could actually be the same across multiple rows. If you might have a diary app where users are allowed to write multiple logs per day. It really depends on how the app and the tables are designed. I'll go back to the ID since I know the ID. Now we can do another select to see that our table changed. And it did. No more knowledge of those 3 pounds of chocolate. Okay, so the user made that change, but then the user decides that they actually want to delete the entire log entry, like maybe because they want to forget that they even had that horrible fight. So in that case, we would need to have code to execute a delete. So we can say delete from diary logs where, and once again, I'm going to use the ID because I know it. And let's select again to see what it looks like. Haha! So we only have one row left, which means that our delete worked. Now, you should be very careful whenever you're doing update or delete, because you want to make sure you're updating the actual rows that you intend to update. You don't want to update the wrong rows or delete the wrong rows and lose that data. In fact, some apps never issues deletes. They never really delete rows. Instead, they add a deleted column to their database, and then they'll do something like deleted equals set deleted to true when the user wants to delete, and then they filter based on deleted equals false in the select queries, something like that. We're back with the database for our diary app. Now, when we first created these tables, like the diary logs table, we decided to store user ID, date, and content. And now I want you to imagine that a few months after we launched this diary app, a user designer suggests adding a "how are you feeling" drop down on each diary entry. And the user would say something like happy or sad or confused. In order to store that, we need to add an emotion column to the table. Now, we could just add it like this, but if this was a database for an app in a real production environment, then we couldn't just edit the create statement because that's something that we actually issued months ago and it's already happened. And if we rerun it, it'll actually remove the current data. And we don't want to lose all the data that we've gotten over these many months. So at this point, after we've done create and after we've got data, we're going to need to use the alter table statement. And to use that, we write alter table and then the name of the table, and then we add, then the name of the column name we're adding, and then the data type of that new column. Great. So now the next time that the user makes an entry, we'll need to specify that column, or we can specify that column. So let's say, all right, let's say they went to Disneyland, and to specify that new column, we're going to put comma emotion, and then here we'll just say happy. Most people are happy that go there. Okay, so let's see what it looks like now if we select it all. So we can see the latest row has happy in the emotion column, and the row before it has that big old null in it. And that is what databases usually do. They fill in null for unspecified values. If we want, we can actually get it to fill in some other value for rows where it wasn't set, and that's what we think of as the default value for a column. So to do that, if we had wanted to do that, we would have put default and then the value in that alter table statement when we ran it. So now you can see instead of null, we see unknown. So that's an option for you when you're adding a column, and just something to keep in mind, depends what you're adding to the database. Okay, so now let me show you something that you rarely do, deleting an entire table. Maybe I would do this if I migrated all the data out of this table into some new table, or if I just got mad and decided to be a horrible person and take a rampage all over our database. That's bad. But anyway, we can do this using the drop table statement. And now if I try to select, what happens? I actually get an error because my table no longer exists, so it can't select from it. So that was a bad idea, and I'll just delete it. You should think really carefully about dropping tables. Do not just drop them willy-nilly. You should also be careful with alter table, especially if you're running it on a table with a lot of rows, because you can have performance issues there. Really, I don't want to scare you, but you should be careful whenever you're making any changes to your database.